I'm Patty Simpson with Simpson Math. In previous videos, we graphed parent functions. In this video, we're going to graph horizontal transformations of those functions. So let's remind ourselves about the square root function. We graphed the square root function, and we graphed these 4 points on the square root function, 0, 0, 1, 1, 4, 2, and 9, 3. And remember, when we graphed that square root function, we had some restrictions on the domain. So we couldn't put in for x, our input value had to be 0 or larger. If we put in a negative number, it made for a non-real output. And so we couldn't graph any of those. So we only put in those values that were above, that were 0 or above. We're now going to graph a transformation of this function. So I'm going to create a new function by just putting a -1 underneath the radical there with the x. So inside the function here, I'm going to put a -1 in there. And let's just see what happens when I do that. And we graph this new function. So before we used the number 0 as our first x input. Let's try that again. If I put 0 in as my input for my x, notice that I end up with a -1 underneath the radical. And that's not real. So we need a value for our input that is going to give us an output that's a real number. So the smallest number that we can use is 1. Because when I input 1, then I get out a 0. And the square root of 0 then is 0. So the smallest input I can put in this time is a 1. And that gives me an output of 0. Now, let's put in 2. I'm going to input in 2, and when I do, 2 minus 1 gives me 1, and the square root of 1 then is 1. That's a nice, 1 turns out to be a nice square root. We get out that nice value, our output is 1. So we put in 2, and we got out 1. So we now have 2 points on this new function. One of them is at 1, 0, and another one is at 2, 1. Now let's put in 3 as our input. If we put in 3 as our input, 3 minus 1 then is 2. And while the square root of 2 is a real number, it's not a pretty number. It's somewhere around 1.4-ish. And it's, irrational. And that's going to be difficult to graph. While it's on the graph, it's just difficult to graph. I would rather this be a nice perfect square so that when it comes out as a nice pretty integer. So let's think about what the next perfect square would be after 1. Well, if we want our output to be 2, then the perfect square that would be underneath here would be 4. And to get to that 4, if we're subtracting 1, well, I would need my input then to be 5. So let's input 5, and then 5 minus 1 gives me 4. Hey, that's a nice perfect square. The square root of 4 then is 2. So my input was 5, and my output was 2. So I'm going to graph that point, 2, 3, 4, 5, up to 2. Now let's graph one more point. So the next one, if 4 is a perfect square, the next perfect square then is a 9. And again, what would I need to put into my input so that it turns out under the radical is equal to 9? Well, since I'm subtracting 1, I'm going to make my input a 10. So that 10 minus 1 equals 9. The square root of 9 is 3. So notice my input was 10 and my output was 3. So here's another point on the graph. This is 5, 6, 7, 8, 9, 10, and up to 3. So my graph looks something like this. and it goes on and on forever that direction. Now, let's just look and see what happened to my graph. So look at the parent and then look at this new function. What happened was we moved each one of our x values this time to the right one spot. The whole function just shifted to the right one spot. And it turns out that when we add or subtract a number inside the function, that it's going to affect our x values. It's going to move or shift this function. It's going to affect my x values of the function. So when I subtract a number, it actually does the opposite of what we think. You know, I would expect it to move to the left, but instead what it did was it moved to the right one. And it turns out that's always going to be true. When it's inside the function, it's going to do the opposite operation of what you think. You know, we're talking about our x's. It's affecting your x's, and we all know how our x's are. They're our x's because they're a bunch of liars. Well, it's true here too. They're a bunch of liars here. So instead of subtracting 1 from all our x values, we just added 1 to all our x values, and it shifted the function to the right one spot. We had a horizontal translation, just shifted it to the right one spot. Here's our cubic function that we graphed, our parent function of that cubic function, -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. And I'm going to graph a function here, a family member. Let's call it h of x. And let's do something maybe like add 4 inside the function. And notice that we're adding this inside the function, that value. And what we now know is that those x's are liars. So instead of shifting this to the right 4, which is what we would expect, it's going to shift our function to the left 4 spots. We're just going to take our parent and move all these points over 4 spots, 4 units. And that's going to be our new function. I'm going to show you algebraically how we can do this. If you know the points for your parent function, like we have graphed here, -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. We can start with those values. And since this is inside the function, it affects our x values. And we can, for each one of our x values on here, just subtract 4 from each one of our x values. Now, I'm going to do something weird because I'm going to put a plus sign right here. But I want to subtract 4 from it, so I'm going to add a -4 because that's the same thing as saying -2 minus 4. A -4 plus a -2 ends up being, I'm just adding that -4, so it's the same as subtracting 4 from it. And when I do that, I end up with a -6, -8, a -5, -1, -4, 0, -3, 1, and -2, 8. So I have these new points on this function. At -6, 1, 2, 3, 4, 5, 6, -8, so -6, -8, -5, -1, -4, 0, -3, 1, and -2, 8. And there's my cubic function, just shifted 4 units to the left. See how my cubic function just moved 4 units to the left? So by adding a -4, that opposite here of the +4, to all my x values, it just shifted it to the left. Now we can check to make sure that that's actually a point on my graph. Let's take this -6 as my input. If I take -6 and add 4 to it, let's see if my output really is -8. So that I have negative 6 plus 4, which gives me a negative 2 cubed. And negative 2 cubed is negative 2 times negative 2 times negative 2. Well, this is a positive 4 times a negative 2 gives me a negative 8. So sure enough, when I input negative 6, I get out, or my output is negative 8. So anytime I'm adding or subtracting inside the function, in other words, if I'm underneath the radical with the x, or if I'm inside the parentheses with the x, or if I'm inside absolute value signs with the x, it has to be inside the function with the x in order for it to affect the x. If it's on the outside of the function, say for instance I had this, that would shift it, that would affect my y values. It's not inside the function. It has to be inside some sort of grouping symbol to let me know that it's inside and affecting the x's. Otherwise, it affects my y. So this one would shift it up 4. And we did a video on this before on vertical transformations. So one horizontal transformation is this translation that just shifts it the opposite direction of what you think based upon what you're adding or subtracting. Another horizontal transformation is if we multiply our function by a number inside that function. So let's look at another example here. Let's take and do the square root of 4x. So with this one, again, notice that my scalar here is inside the function. It's underneath the radical in there with the x. So it's affecting that x value. And again, we know our x is lie. So instead of multiplying times that 4, we're going to take all our x values and divide by 4 to get our new function, to graph this. So the way I do it is I start with my parent function. So we know these 4 points on our parent. You've learned those, you've gotten really good at graphing your parents. And now I'm going to take, because this 4 is inside the function, I'm going to take and I'm going to divide all of these by 4. Or you could say we multiplying by 1/4. That's the same thing as dividing by 4. So I'm going to take each one of those and divide by 4, my x values, so that I have 0 times 1/4 is 0, 1/4 times 1 is 1/4, 1/4 times 4 is 1, 1/4 times 9 is 9/4. So I have these new points on this new function. There's a point at 0, 0 still. There's a point at 1/4, 1, so barely over, at 1/4, 1. There's a point at 1, 2, so 1, 2, and a point at 9/4, 3. So 9/4, you know, 4 goes into 9 2 times with 1 left over, so it's 2 1/4, 2 and a little bit. So I'm going to go over 2 and a little bit and up 3, 1, 2, 3. So my square root function looks something like this. Notice what happened to my square root function. My square root function horizontally shrank. It horizontally compressed, or we had a horizontal dilation there with that number inside, that scalar inside the function being multiplied times that value. So anytime we have a number inside the function multiplying, it's going to stretch or shrink my function. It's going to have a horizontal, our x values are going to be affected, dilation. So let's do the same with our cubic function now. Let's see one that is multiplying by a scalar. So how about we try, let's look at, oh, by the way, let's just test to make sure that these points work. So let's pick one, say 1/4, and input it into our function there. So I'm going to take that 1/4 and substitute it in for x. So 4 times 1/4 is equal to 1, and the square root of 1 is equal to 1. So when I inputted 1/4, I got out 1. That's what we said was going to happen. So it really did graph that function. Now let's graph this one. How about if I have 1/2 x, and I'm cubing that whole quantity there. So in other words, that 1/2 is inside the function, inside there with x. Well, again, because it's inside the function, it's going to affect your x values, but your x's are liars. So instead of multiplying by 1/2 or dividing by 2, we're really going to multiply by 2, by its reciprocal there. So I'm going to take all my parent function original points, so -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. I'm just going to take all those x values and multiply them all by 2. And by multiplying them all by 2, it affects that x. It's going to stretch my, my function there horizontally. So 2 times a -2 gives me a -4. So there's a point on this new function at -4, -2, -4, -2. There's a point at -2, -1, -2, -1. There's a point at 0, 0. There's a point at 2, 1. And there's a point at 4, 8. 4, 8. This should have been at -8, sorry. This one should have been at -8. -4, -8. So now, notice my cubic function. My parent function just got stretched horizontally. So that 1/2 inside of the function stretched it. It affected my x values and stretched that function horizontally. We had a horizontal dilation there. So far we've had a translation. We move it left or right. If we're adding inside the function, and then we have a dilation, we stretch it or shrink it if there's a scalar being multiplied by your function inside. Then there's one last transformation we're going to talk about, and that is if we multiply by a negative. So if I just take this and multiply by a negative number, a -1, inside of here, multiplying by a negative is going to reflect the function. And again, because it's inside the function, it's going to affect my x values. So it's going to affect it horizontally. And so it's going to take these values and just reflect them horizontally. But just like before, I'm going to write down my parent function. So I know these points from my parent. And just like before, it looks like it's multiplying by a -1, but instead let's divide by a -1. But multiplication and division by -1 really turns out to be the same thing. So you can think of it as dividing by -1 or multiplying by -1. You know, -1, the reciprocal of that is still -1. So -1 times 0 is 0, -1 times 1 is -1, -1 times 4 is -4, and -1 times 9 is a -9. So the points on this function, on this new function, are at 0, 0, -1, 1, -4, 2, and -9, 3. So that my function, this new function, looks like this. Notice that all it did was take and reflect my original parent over the y-axis. Just took and reflected it over the y-axis. So let's just check one to make sure. Let's take -4 maybe. And let's just input that -4 to check ourselves. I have a negative inside there, and I'm inputting this -4 in for -x. Inputting my -4 in for my x. And that negative's out front. Well, the negative times the negative makes it a positive. Oh, I have a nice positive number in there. So now the square root of 4 is equal to 2. It does end up being a real number. So my values here work. So when I'm multiplying by a -1 in here, you can think of it as dividing by -1 or just multiplying by the reciprocal of -1, which turns out to still be -1. It just takes my function and reflects it horizontally or over that y-axis. We can do the same thing with this one. If the negative is inside the function, it's inside the function, inside those parentheses with the x, then we can take all of our x values and just multiply them by that reciprocal. So multiply them all by the -1. So that we have -1 times -2 gives me a +2. -1 times -1 gives me a +1. -1 times 0 gives me a 0. -1 times 1 is a -1. And -1 times 2 is a -2. So my points on my new graph are here. And it should take this parent and just reflect it over this y-axis. You know, if I were to fold it on that y-axis, these points on this side should end up on the other side, just reflected. So let's graph those points and just see if it really did do that. So at 2, -8, at 2, -8, at 1, -1, 0, 0, -1, 1, -2, 8. So that cubic function was just reflected over that y-axis. So when our function has something happening inside the function, it's going to affect your x values. When it's outside the function, it affects your y values. Inside the function, we have a horizontal shift or a horizontal dilation or a horizontal reflection. Outside the function, we have a vertical shift or a vertical dilation or a vertical reflection. In the next video, we're going to put multiple operations together and do multiple transformations. Thanks for watching.